Hey guys, welcome to lecture 14 now. This lecture will be going over series. So this is going to be the first lecture where we start to take a look at the Pandas module. It's going to be a really useful module for analyzing data. So let's see how it works. First off, let's go ahead and import NumPy as NP. Then we're going to import Pandas as PD. And from Pandas, we're going to import series and data frame. So series is what we're going to be working with mostly for this lecture. We're going to be using it so often that we don't want to have to write pd.series or pd.dataframe all the time. So we're just going to import those separately. So let's go ahead and click Alt-Enter. Let it import. Cool. So let's create a series. A series is like an array in NumPy, except it has data labels, so it's indexed. To show you what I mean, let's go ahead and just create an object here. And we'll call series kind of in the same way we were calling np.array. And we'll put a little list or array in it. Let's say 3, 6, 9, 12, just multiples of 3. And then let's go ahead and show that. Alt-Enter. Cool. So let's take a look at what's different here. You can see that each value is indexed. So the 0 index we'll call a 3. If we want to just see the values of this series object, we can say call values on it. So dot values. And it'll show us the values in an array. If we want to see the index, we can also say .index. And that will show the index values, 0, 1, 2, 3. So each of these index values corresponds with the series values. So, since index is a big part of series, and later on we'll see data frames as well, let's go ahead and create a series with an index that we specify. So let's go ahead and create a series. I'm going to call this one WW2 CAS. So we're going to make a series for World War II casualties. And I'm getting this information off Wikipedia. So let's say the numbers I'm going to use are 8.7 million. So 1, 2, 1, 2, 3. And you can really put in any values you want here, but this is just for demonstration purposes. 1, 2, 3, 4.3 million, and then 3 million on this guy, 6 zeros, 2.1 million, 3 zeros, and then we'll go with 400,000, 2, 3. So those are the values of the series, and then we can say comma, index equals, and now we're going to make an index for each of these value numbers. So if you know something about World War II, you might guess that that 8.7 million value belongs to the USSR's casualties. They suffered the most casualties in that war as far as any allied nation. Then second ones was Germany's. Third one was actually China. Suffered quite a bit of casualties. Next one was Japan's casualties. And then last one was United States casualties. And let's go ahead and see what that series looks like. Cool. So now our index is actually the country name. And then the value is the number of casualties. So we can use index values to select series values. So to show you what I mean by that, we'll type in our series name and then type in our index name. So let's say we wanted to know the casualties in the United States. We could call that, and then we'd get the 400,000 mark. It really interesting thing we can do with series is check with array operations. So let's say I wanted to check which countries had casualties greater than 4 million. The way I can do that, whoops, sorry for the spelling, add countries. So how can we do that using a series? Well, we can type out our series, and then we can just put in an array operation argument. So, for instance, we'll put in our series greater than 4 million. 1, 3, 1, 2, 3. So we're calling for the values that were greater than 4 million in the series. Let's go ahead and see what happens. Cool. So we get that the USSR and Germany are the two countries that had casualties greater than that 4 million mark. We can also treat a series as an ordered dictionary in Python. So for instance, if we wanted to just check if a index or value was in a series, we could say something like USSR in our series name, and we'll either get a true or false. We should get a true in this case since USSR is in our series, and we do get the true. Since it kind of behaves a bit like a dictionary, we can actually convert a series into a dictionary. So to do that, I'll create a dictionary name, call it www2_dict. And the way to convert a series into a dictionary is just calling to_dict on it. And then I'll show what that looks like. Cool. So now our series is actually turned into a dictionary. Let's say we wanted to convert it back into a series. We can call it whatever we want to name that series. And then we can just feed into the series command that dictionary name. So you can actually feed dictionaries into series. And let's just go ahead and show what that looks like. And now we have a series again. So let's say you were going to pass a dictionary into the series. The index will have the dictionary keys in order. So to show you what I mean by that, let's create a list. So how about we create another list of countries? Let's say China. Oops. These will all be strings. Germany. And you don't have to do this many, but this is just to follow along with the IPython notebook that's on the GitHub link. And let's just do Argentina for another one. So we have our countries. So we have a list of countries, and we can redefine another series. So we'll call it object2. Oops. So we'll have it be a series. We'll pass that World War II dictionary on it, and then we'll set the index to come from our list of countries. And we'll see what that looks like. So if you notice here, Argentina was not in our original dictionary list. So we scroll back up here and see www2_dict only had China, Germany, Japan, USA, USSR. So since Argentina wasn't in there, Pandas, when you pass it through a series with a particular index that didn't have that value, it'll just give a NaN value, so it didn't find it, just that null value. Pandas has built-in methods to find null and replace them or check if they're there or not. Those are is null and not null. So let's take a look at what those look like. So we can call pd.isNull on that object2 we just made. And so it's going to check every value and see if it finds a null value there or not. So Argentina should have true since there was a null value there. Let's say you wanted to do the opposite command. You wanted to find where there were not nulls. So you can just call not null on the object. And then you'll get the opposite. So China, Germany, Japan, USA, and USSR were not nulls since they did have number values there. Argentina is false. It was a null. So it was not null. Sorry. Let's go ahead and check out that World War II series again. Cool. So what we can do, another thing we can do in Pandas is we can add objects to series or series to series, and it'll automatically align the data by index. To show you what I mean by that, let's see what object 2 looked like. So they're the exact same thing, except object 2 has a null value for Argentina. So if we add up our World War II series, add it to object 2, what we should expect to see is in China have 6 million, Germany have 8.6 million, etc. But what we'll expect is that there's no value for Argentina. So let's just see what happens here. Cool. So it lines them up by index. You don't have to specify. Even if they're in the wrong order, it'll still add up the correct values by index. You can give your indexes or your series names. So for instance, object 2, we can name it to have a string name. So if we want to get more specific, we can call it World War II casualties. And then let's show you what happens when you do that. So it'll show you the series, and then I'll show you the name of the series, World War II casualties there. So when you're dealing with Python, it's still going to have this object name, obj2, but the actual series itself has a name, World War II casualties. You can also name the index. So since our index is just a bunch of countries, we can do that by calling index and then calling name on the index. And we'll can label that index as just countries. I don't know why I keep spelling countries. There we go. Countries. And now let's see what that looks like. Cool. And now you've labeled this index countries. It's a bit like almost like Excel, like you're labeling this index column countries. So that's a little intro to series. Next we'll learn about data frames. We're going to be working a lot with series and a lot with data frames, so you're going to see all of this often, so don't worry if you didn't quite get it this first time. You'll see it many, many more times throughout this lecture. Hi everyone, and welcome to lecture 15, and in this lecture we'll be going over data frames. So let's go ahead and start off with our regular imports. So what we're going to do is we're going to import NumPy as NP for array handling. And then what I'm going to do is import, I'm going to say import pandas as PD. And that's the regular convention for importing pandas. And now what I'm going to say is from pandas, import series, comma, data frame. And the reason for that is because we use series and data frames so often in this course that it's better to just import series and data frame on their own than having to write pd.series or pd.dataframe when we use them. So these are three really standard imports that you're going to see constantly throughout this course. Okay, so we're going to learn about data frames. So in order to have a data frame and see what it looks like and how it works, we're going to need some data to play with. So we can go ahead and grab some NFL data from Wikipedia. And the way I'm going to do this is by importing web browser. And this is Python's built-in method to grab a web page. And then I'm going to say websites equal to, and I'm just going to edit copy and edit paste this link, but it's just the wikipedia.org page for the NFL win-loss records, and you can go ahead and check on NB Viewer or on my GitHub for that link there in case you don't want to type it out yourself. And then in order to open this web page, I can just say web browser dot open, and then I open that URL, which I set as an object website. So if I hit Shift Enter, it takes me straight to that web page. So here we have a little bit of a spreadsheet, if you will, of different NFL win-loss records. We have various columns and various rows. So what we're going to do here is there's many ways to create a data frame. But for now, since we're just interested in the inner workings of a data frame and not how to create one from scratch, I'm going to show you how to copy and read data using Pandas in order to grab a data frame. So let's go ahead and just edit copy, edit paste the first 5 rows here. So I've highlighted them. I selected edit copy. And now that whole section is on my clipboard. And I can copy and read data from my clipboard, which is really awesome. And what I'll do here is I'll make an object called NFL_frame. And that's going to be our data frame name. So I have NFL_frame. And to read everything I have on the clipboard, I do pd.read_clipboard. Close parentheses, no extra arguments. And now Pandas has a built-in function to try to read everything that's on your clipboard and set it into a data frame. So if we actually just see what that data frame looks like by calling that object, Shift Enter, you can see that Pandas has transformed everything that was on the clipboard into a data frame. So you can think of a data frame as almost like a spreadsheet or an Excel spreadsheet. And if you notice here on top, we have the column names. And on the left hand here, this very first column, that 0, 1, 2, 3, 4, that's actually the index of the data frame. And Pandas does that automatically. If you notice here, that wasn't actually included, so don't confuse that with the rank. Pandas will automatically make an index here. And in future lectures, we'll learn how to rename that index or make index hierarchies. But for now, let's just learn a bit about the data frame. If you want to grab the column names off a data frame, that's actually quite simple with Pandas. You just call NFL_frame dot columns, and then Pandas will return to you the name of every single column. And don't worry about this U. But now you have the names that you need to call in order to get those columns. And there's 2 ways you can grab a column name. You can have your data frame name and then dot the column name, and it will return to you a series with that those values in that column. So you can see here we have the rank, or we could also say, for instance, team, and it'll return the teams. Now you're not going to be able to do this with columns that have more than one word in it. For example, first season. The way you grab those columns is with an index call, if you will. And I say index just because of the formatting of the brackets, not because it's an actual index call. So hopefully that wasn't too confusing. But you can call it like this for first season. And now we have all the values in that first season column. So it's just important to note, you need to spell and format your column name exactly like it's spelled in your data frame. And the way you can make sure of that is just by calling this dot columns, and Pandas will report to you what it's expecting to be called if it wants you to grab that column. So first season matches up with first season here. Great. So let's go ahead and grab multiple columns. So we can do that. We can actually call a data frame. So we can say data frame, grab data from the NFL underscore frame, and set the columns we want to grab. And I can actually pass a list of columns. So I'll say I want the team column, the first season column, and then the total games. So what I've done now is I've actually created a new data frame from my NFL frame, and I've grabbed the columns that I wanted. So now I have my team, my first season, and my total games played. And let's go ahead and check what happens if we ask for a column that doesn't exist. So for instance, let's say I just copy and paste this. And let's say I had included in my list a stadium column. Now if you note here in our original data frame, there is no stadium column. So let's see how Pandas deals with this. I'll shift enter here. And instead of returning an error, what's really nice about Pandas is it just fills in that column with all null or non-applicable values. So you have a bunch of null values here, but your data frame still works. Great. So now let's go ahead and see how we can retrieve rows off a data frame. So let's go ahead and see what our data frame looks like again. NFL frame. Great. Now, another quick note to say, if I wanted to retrieve just the first few rows of a data frame, I could say NFL underscore frame, your data frame name, dot head, and it'll retrieve to you the first 5 rows. Or if you pass a number through it, it'll retrieve the first 3 rows, the first 2 rows, etc., etc. And if you want the end rows, you can do the same with just tail. And now it'll give you the last 2, the last 3. By default, that number is always 5. So if you just call head or tail here, since we only have 5 rows, it'll actually just return the whole data frame in this particular case. But you can use tail and head to grab either the last rows or the first rows, depending on which one you call. So that's one way to grab rows. But let's say we want to retrieve rows on a particular index. The way we can do that is by calling our data frame, NFL frame, and then we pass the ix method for index. And then let's say I want everything that's on index 3. And that gives me back the Miami's Dolphins information. So remember Pandas, and in Python in general with NumPy, indexing always starts at 0. So I'm grabbing the 4th column or 4th row by inputting index 3. And now I have a returned object with all the information on that row. So that's one way you can retrieve information. You can also assign values to entire columns. So for instance, I grab my NFL frame, and let's go ahead and grab that stadium column. And I can set my equal sign in order to assign values to it. So I can see, let's say Levi's stadium. And something to note to be careful here, since I have a single quote there, I need to use double quotes to end my string. Just a quick note. So what is this going to do if we go ahead and check it out? Now let's see what happened to our data frame. So Pandas now, if you only pass that one argument to assigning it to an entire column, it'll fill in that entire column with that particular stadium name or whatever value you happen to be working with. Great. So let's try another example to make sure we really understand this. I'll grab my data frame column again, I'll do it the stadium column again. And let's say I wanted to pass in some numbers. So just put numbers for every stadium, 0, 1, 2, 3, 4, 5. I can do that by just calling np.arrange, as we've seen in the past. And since I have 5 rows, I need to pass one more in my arrange. And what was the error here? If we look at it, notice the length of values does not match the length of index. So I actually only have, I only have 5 rows there. So now that makes sense. Remember, the indexing starts at 0. So 5 was the correct there. I apologize for that. And now if we look at what happens with our data frame, now we have 0, 1, 2, 3, 4. So those numbers that NumPy arranged for us. And again, sorry about that previous mistake, but since you have 5 rows, you import NumPy arrange 5. Okay, great. So what if I want to add a series to a data frame? How do I do that? I can say stadiums, let's make a new object called stadiums, is equal to series. And then let's go ahead and pass a list. So I'll say, again, Levi's Stadium. And then I'll have my AT&T Stadium as another series object. And I'll set this to have an index of 50. Okay, so let's see what stadiums looks like now. Great. So if you notice, we actually are going to be out of index. So let's go ahead and change that to 40. Make sure that works. Okay, great. So what I have here now is a series where I've put in 2 values into my series as a list, and I've assigned them that index. So 1, 4 for Levi Stadium, and then a 0 index for AT&T Stadium. So how do I input that into my data frame? Well, it's actually pretty simple. I just say NFL underscore frame. I call that data frame. And then I call that column that's on that data frame. And then just set it equal to stadiums. And now if we check out what that data frame looks like, we can see that it's actually assigned stadiums to the NFL data frame. And again, Pandas takes care of null values really, really well and fill those in for you where it didn't have the information. You can also delete entire columns, and you can do that just by calling del and then whatever the column you want to delete is. So in this case, let's go ahead and delete that stadium column. And if we check out what the data frame looks like now, you can see that entire column has been deleted. Great. So we went over how to kind of mess around with a data frame, and we constructed that data frame just by copying and pasting. You can also construct data frames by passing in dictionaries, and I'll show you how to do that right now. So let's just go ahead and make another object called data, and I'm going to make a dictionary for this. So my dictionary is going to have 2 keys. It's going to have city, and that's going to be a list that we'll fill in a little bit, and then it's also going to have population, and again that will be a list. So let's say I want 3 different entries here. So let's go SF, LA, NYC, and then my population, I just looked up these numbers a little earlier, so it's going to be 83700, comma 3881123. So LA has quite a large population, and then 1, 2, 3, 4. Okay. So now I have my dictionary here. Let's run it, make sure it works out. Okay, great. So you can construct a data frame just by passing a dictionary. And I'll show you how to do that. So we'll make a new data frame called city_frame. I'll have it be called data frame, and I can pass in that dictionary. And let's go ahead and see what that looks like. Great. So Pandas can automatically take in a dictionary as long as it's constructed correctly and these lists match up as far as number of data points in them, and it'll automatically construct that data frame for you. So there's a ton of ways to create data frames in Pandas, and we'll be exploring them as we move on throughout this course. But for a full way of creating data frames, I'm going to edit, copy, and edit paste this link here. You can just check out the documentation, and if you go to the link here provided, pandas.dataframe, it gives you all the API methods you can use on that data frame. And if you just keep exploring throughout this documentation on data frames, you'll learn all the different ways you can construct data frames. So from dictionaries, from records, from CSV files, and we'll learn how to do all that throughout this course. But for now, that's just a quick overview on what the data frame is in Pandas. You can think of it just basically as a spreadsheet, and hopefully a few methods for you to mess around with columns and rows names. So this is going to be one of our main tools in data analysis throughout this course. So I encourage you to check out the documentation on the Pandas website. All right, thanks guys, and I'll see you at the next lecture. Hey guys, welcome to lecture 16. This lecture is going to be on index objects, which we've been learning about in series and data frames. Let's start off as always, just importing the regular stuff. You can go ahead and just copy and paste this if you want to. We're going to import series and data frame, and then import pandas as PD. Okay, so let's just go over quickly about series and index objects. So we'll create a series, we'll call it my_ser, and we'll create this series by, let's just make it a 1, 2, 3, 4 array, or I should say list in this case. We'll pass a list, and then we'll define the index as A, B, C, and D. Okay, and then we can just take a quick look at what that appears. Alright, so now your index is A, B, C, D, since you specifically set that through that list, and your series is 1, 2, 3, 4. Let's say I wanted to get the index. I can set that as an object. I can say my index, and you might remember this from previous lectures. You can just get the index by saying .index. Let's go ahead and show what we set. Cool. So now we have our index unit. Just don't worry about this U. It won't actually be part of the index. It's just indicating that it is the index. So we have A, B, C, D, and it's object type. We can grab index values just by calling them. So let's say you wanted to grab that number 2 index value. Think about what you'd expect to pop up. So it's C. If you were thinking B was going to pop up, remember that the index starts at 0. So it'd be 0, 1, 2. So out of that list, the third object appeared since we called it 2. 0, 1, 2. So that should be letter C. Let's say we wanted everything past 2. Then you might remember just from knowing Python that you can use a colon to indicate everything. So this should get us everything past the second index marker. And it does. It gives us C and then D. So those are basically the main ways to mess around with an index. .index to call it off the series, and then you can input specific values you want just by calling them through the array's index value. What happens if you try to change an index value is a good thing to test. So check my index, the very first one, 0. We should get an A out, and we do. If we wanted to change this, let's say we try to do 0, and let's say we try to change it to Z. What would happen? Well, you get an error, which is good. So indexes don't support mutable operations. And what that means is that indexes are immutable, so you can't change them like this. You'd have to pass an entire new index, which is good because that makes the data frames or series really stable. You can't just be changing index values willy-nilly, in a sense. If you wanted to re-index, we can do that. So that will be lecture 17 on re-indexing. Take a look and just make sure you understood everything in this lecture. We'll be doing tons of indexing and re-indexing in the course. This is just a brief intro on it. So you'll see this again and again. Alright, I'll see you at lecture 17 to learn about re-indexing. Hey guys, welcome to lecture 17. This will be on re-indexing. So last lecture we went a little bit over indexes, how they work, how you can call certain index values. We're going to learn how you can re-index and change the index if you wanted to. So we're going to import the usual NumPy as NP. From Pandas, we're going to import series and data frame. We're going to import Pandas as PD. And the last thing we're going to do, which is a little different from usual, is from numpy.random, we're going to import the rand_n, which will grab numbers with a normal distribution. So we'll just use this later in this lecture just to grab some random numbers. So let's go Alt-Enter, import all the libraries we'll be using. Let's go ahead and create a new series. We'll just call it SCR1. And we'll build this series the usual method. So we'll call the self to be just a list, 1, 2, 3, 4. And then we'll set the index as A, B, C, D. And then we'll show what that looks like. Cool, so now we have a series A, B, C, D indexed, and the values are 1, 2, 3, 4. So let's say you wanted to re-index, to rearrange the data to a new index. How would this work? To show you, let's go ahead and start building a new series. We'll call it SCR2. And this new series is going to be built off series 1. And now we're going to call re-index on SCR1, our first series. And we'll pass a new re-indexing list. So we'll call it A, B, C, D, and we'll go all the way to F on this new index and see what happens. Let's go ahead and show it. Awesome. So Pandas, since it's very good at dealing with missing value points, when you re-indexed it, E and F didn't exist in your first series, this SCR1, so it automatically just gave it null values for E and F, which is really nice. So you won't have to worry about doing a perfect re-index or not having values for your re-index. Pandas will automatically give you null values there. We can also fill in values for new indices we write. So for example, if we reindex our second series that we just made, we'll go A, B, C, D, E, F, and now we'll bring it all the way to G. If we wanted to fill certain values, we can pass the argument fill underscore value and set that equal to something. In this case, I'll set it equal to 0. So what that should do is instead of passing a null, it will pass a 0 as the new index values. Cool, and that worked. So our original series 2 was 1, 2, 3, 4, null, null with E and F. I re-indexed it, and I added G to the index, and I also passed the argument fill underscore value equals 0. So since G was the new index, it'll be filled as a 0, which we saw here. E and F stay null since those existed in the previous index. All right, cool. You can use particular methods for filling values. So to demonstrate that, let's go ahead and create a third series. We'll call it SCR3. And in this case, let's go ahead and pass just a list of countries as the series. USA, Mexico, and Canada. Alright. And we'll have the index just be some list of numbers. Let's go 0, 5, 10. Alright. Let's go ahead and show that. Cool. So we have our third series. The values are just USA, Mexico, Canada, and the index is 0, 5, 10. Let's say we wanted to re-index this all the way from 0 to 14. How would we do that? And what would we want to fill? So we can call reindex, and for the reindex self, we'll just pass range 15. And to give you a better idea of what the range will do, I'll actually pass it separately. So I'll make a new object called a ranger and call this range 15. And let's take a look at what ranger is. So range just makes a list of 15 points, as we've seen before in NumPy. And it goes from 0 to 14, since the index starts at 0 for arrays. So back to re-indexing this third series we made. I'll call ranger, which would be the same as just typing range parentheses 15 in there as the argument. And I can pass the argument method. So what kind of method do we want to fill for interpolating values between the new indices that we're going to put into it? So one argument we can pass is ffill. So this stands for forward fill. So what's going to happen is right now our index on series 3 is 0, 5, and 10. But we're going to be filling it with a bunch of values. So 0 will have USA. 1, 2, 3, 4 would be null if we didn't have a method argument here. So what's going to happen instead when we say forward fill, it's going to grab the previous value, USA, and forward fill it for the next indices until it hits something that already had a value. So that will be 5, Mexico. And then for 6, 7, 8, 9, it's going to forward fill those with a previous value, which was Mexico. And then once it hits 10, that already has a value, Canada, and it'll forward fill the rest of them, Canada. So let's see if that works. And that's what we get. So it forward filled USA into the next 4 index values. It forward filled Mexico into the next 4 index values, and it forward filled Canada. There's different methods you can pass. You can check out the documentation for the different methods. You can do a backwards fill, which would be basically opposite. Mexico would then fill everything back, and Canada would fill everything back, and then these guys would be nulls since there's nothing ahead of them. So let's say you wanted to reindex rows, or not just rows, but columns, or even both of them. How would you do that? So in order to see that effect, we'll make a whole data frame. So we'll call this object dFrame. We'll call data frame. And how should we build this data frame? Let's say, what do we want the self to be? We'll call 25 random numbers. And then what we're going to do is pass or call reshape on this. So rand and 25 will just get you a list from 0 to 24. And then if we call reshape, we can actually, instead of having it be just a straight vector, we can indicate it to be a matrix. So this can be a 5 by 5 matrix. So those will be the values of the data frame. Should be a random numbers 5 by 5. Let's go ahead and give it an index. So the index for all the rows. Again, we'll just use a letter index here. And let's skip C just to show you an effect that later on. And we'll go to F. So we have 5, one for each row of this 5 by 5 matrix. And then if we want to set the columns, we just pass the columns argument. And we'll just label them call 1, call 2, and I'm running out of space here, so I'm actually going to start this on a new line. Remember to have the comma there. Call 2, call 3, call 4, and there's going to be 5 columns since it's a 5 by 5 matrix, so we'll stop with call 5. So that will be our data frame. It's going to be, we asked for 25 random numbers. We reshaped them into a 5 by 5 array, so that's the values of that data frame. Then we set the index of the rows just to be A, B, D, E, F. We skip C. And the columns will just be called call 1, 2, 3, 4, 5. You can call the columns whatever you want. And then we'll type dFrame just so we can see what it looks like. Cool. So like I said, A, B, D, E, F is your index for your rows, and we have our column names, and you can see the random numbers that are filled in the data frame. So since we forgot C, let's reindex onto the data frame. So we'll call a new data frame, dFrame2, and we'll have that be equal to the old data frame with a reindex called on it. And in this new new index, we won't forget C. And then we'll go all the way to F. So what's going to happen when we do this? Let's find out. We'll call dFrame2. Think about what you think is going to happen and how Pandas deals with the reindex values. And if your intuition is right, then you should have guessed that it would add null values in for that entire C row, just as if we scroll up, it did before for the values in the series when it was reindexed. Cool. We can also explicitly reindex columns. So let's go ahead and just make a list called new columns. Call it call 1, call 2, and let's go all the way out to call 6 this time, since we only went to 5 previously. So we make a list, new columns, and now we're going to grab the D frame 2 that we just made. It's this one here above with that new C row, and we're going to call reindex on it. And the reindex, for a reindexing of the columns, you have to call columns specifically, and then you can say equals. And we could either manually type in this list or just call it using its name, new columns. So think about what you expect the data frame to look like now. Hopefully you guessed right. Column 6, you added it in, and Pandas automatically put in null values for that entire column. Cool. You can reindex really quickly just using .ix. We'll see more of this in the future. We've seen a little bit of it in the original indexing lecture, but we'll see about much more in the future. Just to give you a little taste of it, let's see the original data frame, D frame. And we can call IX to reindex. The first argument it takes is your rows, so we'll just call it A, B, C, D, E, F. And then the second argument it'll take is the columns, so we'll just pass new columns. So this is our original D frame. Remember, it's missing the C and it doesn't have that column 6. And now using IX, we're going to really quickly reindex it just in one single quick step. So Alt Enter to see that, and boom, now you have the same D frame that was D frame 2. So instead of having to reindex everything separately, the faster way to do it is using IX, and we'll see more of this in the future. Alright, excellent. So I'll see you in lecture 18, and we'll learn more about data frames and how they work. Alright guys, welcome to lecture 18. This will be about dropping entries from data frames in series. We'll just call it drop entry. So let's take a look at how this works. First off, we're going to import the usual. You might just be copying and pasting now, but I'll just always be typing it out. Import NumPy. Then from Pandas, we're going to import series and data frame. And then we're going to import Pandas as PD. Alt Enter. Alright, great. So let's create a new series to play with. We'll call it SCR1. Call series, and what are we going to pass as the series? Well, we'll just pass NumPy's arrange function. We'll have it just be 3, should be 0, 1, 2, and then I'll set the index as A, B, C. Alright, let's go ahead and show that series. Cool, so we have our range 0, 1, 2, that was 3 points, and our index A, B, C. So what if we wanted to drop an index? How would we do that? Well, in Pandas, it's actually pretty easy. You just say call drop on your series, and then put the object you want to drop, so that index label. So let's say we wanted to drop B, and then boom, that whole row is dropped. Anything that was indexed with B is now dropped. So let's look at how this works with a data frame. In order to do that, let's make a data frame. So we'll make D frame 1, call data frame, and let's go ahead and input we'll use NumPy arrange to create a array of 9 numbers, and then we'll call reshape on it like we've done in the past, and we'll just make it a 3 by 3 matrix. Awesome. So now that we have our data value points, let's create an index. In this case, I'm just going to make the index city initials just to mix it up a bit. And last, we just need to name the columns. And we do that by passing the columns argument. And let's make a list. So I'll make one pop for population, maybe another for size, and then a year column. We won't actually be filling this with real data, so you can call them whatever you want. And let's go ahead and show data the dframe 1 to see what we got. Alright, so we have our range of 9 points, 0, 1, 2, 3, 4, 5, 6, 7, 8, arranged or reshaped into a 3 by 3 matrix. We have our index, SF, LA, and Y, and the column names pop, size, and year. So if we want to drop a row, we do it just like we did for a data frame. We call a drop on the data frame, and then give the index of the row we want to drop. So if we wanted to drop the index LA row, we'll do that, and that will get rid of that. So this doesn't actually permanently affect your array. If you wanted that to happen, you'd have to save another array with the drop. And now if I see dframe 2 and show it, it's going to drop it permanently. But the original dframe, dframe 1 will still retain LA. So what if we wanted to drop a column? Well, it's a very similar process. So dframe 1, drop. You give the column name, year. But now since we're not going to be dropping a row, we need to specify which axis we want to use. And in this case, the axis for the columns is axis 1. By default, the drop uses axis 0, which would be your rows. The columns would be axis 1. And so you can see we've dropped the year column and now just have a 3 by 2. And that's about it for dropping entries. You just use .drop. If you want to drop a row, you just gotta name the index of that row and it'll drop it for you. If you want to drop a column, just gotta name the column and then specify that it's on the 1 axis, or axis equal to 1. Cool. So next we're going to learn about selecting entries in the data frame. Alright, I'll see you there. Hey guys, welcome to lecture 19. This will be selecting entries. Oops. Alright, so as always, import the usual. Import pandas as PD, and then from pandas import series data frame. Alright, awesome. So let's just create a series. We'll call it SCR1. And let's go ahead and again use the NumPy arrange method. We'll just have it be 3 points. And we'll set the index as usual for 3 points, just A, B, C. Awesome. And what I'm going to do here is I'm going to set series 1 equals to every value doubled in series 1. And I'm going to do that to avoid some confusion in the future, and you'll see what I mean later. So we created a series. Originally it would have just been 0, 1, 2, but we doubled every value in it with some multiplication. So now it's 0, 2, 4. And that created our series, or SER1, that series. Alright, so let's learn how we can select some data. So we can grab entries by the index name on a series. So if we call that series, we can just grab it by the index. So for instance, if I wanted the 2 value, its index is B. So if I call that, I'll grab that 2. Or I can just grab it by its numerical value of the index, that is. So the index will always have a numerical value starting at 0. So A is 0, B is 1, C is 2. This is why I multiplied the values by 2 to avoid any confusion. So if I said SER1 and called the 1 index on it, that will be the same as the B index, and I'll get the 2 value out. We can also grab it by a range, so I can call from 0 to 3, and that will give me all of them. Awesome. So that's the 0, 1, and 2. 3 was not inclusive there. And we can also grab it by a range of index values as well. So the actual index value names. And I can do that by passing a list. So let's say I just wanted those first 2 values. That'll get me the A and B value. So instead of using the numerical index values 0, 1, 2, I can actually call them by their names. We can also grab by logic, and what I mean by that is just using some Boolean logic or just basic equations. So I'll show you an example. So we have our series, and what do we want to grab from it? We can say, go ahead and grab everywhere that the series is greater than 3. And if I select that, it gives me C4, which was the only value that was greater than 3. And we can also set values using this kind of method. So we can say, where it's greater than 3, where series 1 is greater than 3, let's go ahead and set those values equal to 10. And then let's show what it looks like. And now it's replaced any values that are greater than 3 to 10. Awesome. So now that we've seen how selecting entries works in a series, let's go ahead and see how it works in a data frame. So we'll start by making a data frame. First thing we're going to pass are the actual entries, those values. So we'll do it by just getting an array of 25 entries, and let's go ahead and reshape this into a 5 by 5 array, or a matrix, sorry. What's next? We gotta set up the index if we want to have it actually labeled, and we'll use cities again. What else is there? San Francisco. Let's go with DC for Washington DC, and then maybe not sure, Chai for Chicago. And then we can also have the columns by passing the columns argument, and I'm going to start a new line here. Make sure you have this comma here before you start the columns argument. This comma. And then we can go ahead and pass a list. We'll need it to be 5 letters long, so we'll just do A, B, C, D, E. Perfect. And then we'll just show that D frame, that data frame. Cool. So we have our index labeled by cities, and our columns labeled by letters. The data itself was just an array from 0 to 24 that we've reshaped into a 5 by 5 matrix. So how do we select data from a data frame? Well, you can select it by column name. So you can call the B column, and that will grab you all the values in that B column. So 1, 6, 11, 16, 21. You can select multiple columns in the same manner just by passing a list. Notice how I'm using 2 sets of brackets here. So if we wanted BE, we call that, and then we get the BE columns. And just like we did in the series, we can use Boolean logic as well. So we can say, give me the data frame values where C column, is greater than 8. And if we pass that, it's going to give us this as a return. So it's giving you every row as the answer where C was greater than 8. So if we look back at our original D frame, the first 2 rows, C was less than 8. The last 3, it was greater than 8. So it passed. It gave us the last 3 rows of the entire data frame. You can also show a Boolean data frame, and a Boolean data frame will just have Boolean values, so true and false. And I can do that just by asking, hey, where is D frame greater than 10? And then it'll give me a Boolean data frame, so everywhere that's labeled false, you can see the data frame was less than 10, and everywhere that's true, it was greater than 10. Cool. And as we previously discussed, we can use IX to label index. So to show you an example, we can say dframe IX, and we can pass LA, and it's going to give us those LA values. So that LA row was 5, 6, 7, 8, 9, and it's given us 5, 6, 7, 8, 9, and the columns as the index values. So another quick example, we can also do this by asking for the 1 row value. So remember, indexing starts at 0. So 0, 1, so that should also be LA. 0 was NYC. And if we check that out, what do we get? We get the same thing as calling LA. Cool. So we'll be selecting entries a lot during this course, so you're going to be seeing this over and over again. And hopefully, as we create more data frames and create more series, you're going to feel really comfortable just making data frames right off the bat with NumPy arrange and then creating index lists and column lists. Alright, awesome. So the next lecture we'll learn about data alignment. I'll see you there. Hey guys, welcome to lecture 20. So what we're going to learn about here is data alignment. Alright, so we're going to learn about arithmetic between data frames with different index values. Start off as always, import NumPy as NP, import Pandas as PD, and then from Pandas, import series and data frame. Okay, so let's go ahead and start by making 2 series. First one, we'll just pass a list 0, 1, 2, and then we'll make the index letters. Whoops. We'll have to pass a list of letters for brackets. There we go. A, B, C. And let's go ahead and show that. Alright, so we have 0, 1, 2, index ABC. Let's go ahead and make the second one. We'll call series, and we'll call 3, 4, 5, 6. So it's going to be one longer than the first series we made. And the index will pass A, B, C, D. Now let's go ahead and show that just to see what it looks like. Alright, 3, 4, 5, 6, A, B, C, D. Awesome. So what's going to happen when we add these together? Let's go ahead and find out. So SCR1 plus SCR2. So let's take a look at what happened. Pandas added up the values where the index matched. So A in the first series was 0, A in the second series is 3, so 0 plus 3 is 3. What it wasn't able to do is add where series 1 didn't have an index value matching. So series 2 had a value of 6 at D, but since series 1 didn't have a D index, it's going to replace it with a null. So the null values will be added automatically if you don't have a matching index in both series. So let's see what's going to happen with data frames if we try something similar. So I'll make D frame 1 my first data frame. And we'll pass NP arrange. We'll have it be for long, and we're going to reshape this into a 2 by 2 matrix. We'll make columns. An interesting way to do this is we can call list, which is a Python function, and we can put in A, B as a string, and what list is going to do is it's going to make a list out of A and B. So the columns are just going to be A and B. This is just a little trick we can use in the future to save some time. And then index, well, I'll just use cities again. Oops, LA. Alright, and then let's go ahead and take a look at what that data frame looks like. Whoops. So I accidentally forgot a non-keyword argument after a keyword, and that is the equal sign here. So we forgot to say index equals. Now let's see if it works, and it does. Awesome. So I have my data frame 0, 1, 2, 3. It's got reshaped to a 2 by 2 matrix, and the cities are the index and the letters are the column values. Let's make a second data frame in a similar fashion. In this case, I'm going to make a 9 point array and reshape this into, you probably guessed it already, a 3 by 3. We'll have the columns. We'll use our little list function trick again. And in this case, we're going to need 2. So I'm going to say ADC. I'm skipping B on purpose so we can see its effects later. And then index will equal NYC SF and LA, since that was in the last one. And notice something I was accidentally doing here. I accidentally dragged this parentheses, and you can see that IPython will highlight which one it's matched up to. So I'm going to delete it here and bring it back down to reshape. Awesome. And then let's go ahead and see what that looks like. Cool. So now we have our 3 by 3 ADC column data frame. So what happens when you add D frame 1 to D frame 2? Take a moment, pause the video, see if you can guess at what's going to happen. Look back and see what happened to the series, and try to think of what's going to happen when we add these two data frames together. Alright, let's take a look. So the only two that it was able to successfully add was the A column for the values LA and NYC. That's because those were the only two where the row index and the column matched up. The rest of them had null values. So what if we wanted to replace the null values? What could we do? Well, we can call our dframe 1, take a quick gander at what it looks like, and then say dframe 1, we can use add. So this is a we can call add to it instead of adding it directly with that plus sign. So we'll say add. First thing we're going to do is what are we going to add to this dframe? I'm sorry, dframe 1. Well, we can add dframe 2 to it, and then another argument we can pass are the fill values. So I'll put fill underscore value, we've seen this before in the past, as 0. So what's going to happen now is something a little different. You can see we only have one null value now, and that was the B for SF. So if we look at dframe 2, I'll just type it out again. For instance, B of LA or LAB was a 3 value in dframe 1, and there was no B column here. So previously that would have resulted in a null, but since we had our fill value be 0, it filled in zeros for the data frame, the second data frame's value. So then it kept the original dframe 1 value. So BLA was 3, and now BLA is 3 in this added data frame. So this is going to be a really important tool if you're going to be adding different size data frames but don't want to lose all your data to null values. You can just select fill values to be 0 and it'll use the original values of the dframe 1 unless there is a value. So what about operations between a series and the data frame? So we see what the second data frame there looks like. Let's go ahead and create a new series. We'll call it SER3. And we're just going to make it from the second data frame's 0th row. And I can do that just by calling it like that. And let's take a look at what it actually looks like. So here's dframe 2. That was a 0th row, so the NYC row, I made a series out of it, 0, 1, 2, and its index are the column names ADC. So we can use arithmetic on it, just some operations. So we can say something like dframe 2 minus that third series we just made, and that'll just work perfectly since there's values for every column in that NYC row, so it's going to subtract it completely from dframe 2. Alright, so up next we're going to learn about sorting and ranking. I'll see you there. Hey guys, welcome to lecture 21. In this lecture we're going to be learning about ranking and sorting. So how to use rank and sort. Let's go ahead and check it out. First off, we're going to import the usual stuff. Import NumPy as NP. From Pandas, we'll import series and data frame. And then finally we'll import Pandas as PD. Alt-Enter to get a new cell. Alright, cool. So, as usual, how about we make a series to play with? So I'll make the series and I'll call Python's range function. I'll get 3 points, and then I'll pass an index argument, and we'll say it's CAB index, And let's just see what that looks like now. And the reason it's not in ABC order is so we can actually use sort. So if I wanted to sort this index, how would I do it? It's really easy. You just take your series name and then you call sort index on it. Close parentheses. We don't have to pass any additional arguments there. Let's go ahead and see what happened. Awesome. So now my index is sorted, A, B, C, and it sorted its values associated with that index along with it. Let's say you wanted to order a series by its values, not by its index. Well, you can do that too. So if I wanted the order 0, 1, 2, basically what we had before, I can take my series and the argument I can, or what I can call on it is order with close parentheses. And order will order it by the values themselves, 0, 1, 2. When sort index, we'll sort it by the index values, A, B, C. So that's sorting. And let's get an idea of how ranking works. So in order to do that, I'm going to import, as we've done before in the past, from the NumPy random library. I'll import rand_n. Let's go ahead and do that. And then make a new series. And this series is just going to be 10 random numbers. So I'll pass in the 10 argument. And we'll see what that looks like. Awesome. So now we have 10 random numbers. And let's say I wanted to sort them and see how they rank. So let's just sort them. ser2.sort. And now let's check it out. All right. So now we've sorted all the values in this series from lowest to highest. That means that every value in this series had a rank. If you notice, the index values are all jumbled up because they were in order at first, but the values weren't. So when you sorted it sorted it by value, and now your index values are a little jumbled up. What if you wanted to know the actual ranking of each value in the series? Well, I can show you by calling rank on our series. And you notice rank then shows in perfect order 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this rank value is what is actually being sorted. So previously all these numbers had a rank value, and then what sort does is it takes the rank value and just puts it in ascending order. And that's how ranking and sorting works. So on the left column we see the original index value, and on the right we see its rank value. Let's go ahead and, just to get a clearer picture on that, we'll do it one more time. We'll make a third series. I'll call another random 10. See what that looks like. Okay, so I have, again, 10 random numbers. Let's go ahead and check out their rank right now before I sort them. Oops, sorry. Series 3. Alright, so you see the ranking, while the index is in perfect order, the rankings are all over the place. So what will happen when I sort and then check the rank, you'll see that the rankings are now in order, but the index that was associated to each value is all mixed up. And then let's check out what the series actually looks like now, series 3, and like we saw before, everything is now sorted by its rank. So that's the relationship between rank and sort. Each of these values has a ranking, and sort just ranks them, or yeah, sort just ranks them by that ranking value. Alright, cool. So next up on lecture 22, we'll learn about using descriptive statistics on data frames. I'll see you there. Hey guys, welcome to lecture 22. In this lecture we're going to be going over some summary statistics. Sorry. So Pandas comes with some really good methods you can call on data frames. They're all built in, and you can summarize data in these method frames. So let's go ahead and start off with importing NumPy as NP. Basically our usual stuff, importing from Pandas, import series and data frame, and then import Pandas as PD. Awesome. First off, what we're going to want to do is create a data frame to work with. And I'm going to construct this data frame from a matrix that I built using np.array, like we've done in the past before. Let's go ahead and make this a 2x3 matrix. So the first row, I'm going to give it 1, 2, and then I'm going to do something a little different that we haven't seen in the past before. I'm going to make the third value np.nan. So I'm going to make it a null value, and you'll see why I do that later. And then same thing for the first value in the second row. It's also going to be nan, and then I'll give it some numbers there. So let's go ahead and make that matrix. And now to build my data frame, we'll call it dframe1. I'll pass the matrix I just made. We'll give it an index. Index will be AB. And the columns, we'll call them 1, 2, and 3. All right, let's see what that looks like. So for my matrix, that was 1, 2, null, null, 3, 4. Now we have it in a data frame with A and B index, and the columns are called 1, 2, and 3. Cool. So let's see the sum method in action here. Just take a look at what happens. So what is this going to do? So sum on a data frame, it's going to sum up all the values for each column. So for instance, the 2 column, 2 plus 3 is 5. And you notice something that's really nice about Pandas when you're calling sum. It's going to ignore null values, so it's not going to crash on you just because you have null values there. It's going to be able to just ignore them and treat them as zeros, so it's just going to skip them over. Okay, what if we wanted to add up the rows? Well, you can do it the exact same way. You just got to indicate that your axis is 1. And now you've summed up the rows instead. So row A, 1 plus 2 is 3. And then row B, you have 3 plus 4 equals 7. Cool. What other methods can you call on a data frame? Well, you can call the min method on a data frame. And what is that going to do? Let's take a look at our data frame again just to get a picture. The min method is going to find the minimum value in each column. So with the 1 column, the 2 column, 3 column, the minimum value, if we take a look at the 2 column, it was 2. Since it's comparing 2 and 3, 2 is the smaller number there, so 2 was the minimum value. So it returns the 1, 2, and 4 values there, the minimum values for each column. What if you wanted to find the index of the minimum value in each column? There's a method we can pass there as well. In that case, it's just going to be idxmin, and that's going to give you the index of each of those minimum values. So if we take a look back at the minimum values that were 1, 2, and 4, which index were they in? So the 1 column, its minimum value is 1, and if we look back at our data frame, the index for that value is A. So A is the index of the minimum column or the minimum value for column 1. Let's go ahead and look at column 2. What was its minimum value? Its minimum value was 2, and the index for that minimum value was A. And then finally, column 3, its minimum value was 4, and the index for that one was B. And so idxmin will return the index of the minimum values in each column. All right. You can do the same thing with finding the maximum values. They're the exact same methods, but instead of writing min, you just write max. So let's go ahead and see our data frame one more time. 1, 2, null, null, 3, 4. We can also do an accumulation sum if you wanted to. The way to do that, it's really easy. Just come sum, call it on. Whoops. Remember we called it dframe1. Go ahead and pass that. And now you have the accumulation sum along the columns. So the only place you're going to see the difference there is in column 2, where column 2 index B, its value is now 5. Since the accumulation sum was 2 plus 3, it changes that value to 5. Cool. So now that we've gone over some basic methods, let's get into the real useful features of Pandas. So one of the most useful features is something, a method called describe. Let's go ahead and just see what that looks like. So if we call describe method, I'm sorry, there we go, dframe1. So what does describe do? So describe is going to provide summary statistics for your data frame. So it's going to give you a bunch of statistics on your data frame. It's going to count how many objects you have, going to give you this mean, the standard deviation, other statistics to find values within certain distributions or probabilities beyond the mean. And you can get that all just by passing describe. Cool. So speaking of statistics, what else can we get? We can also get information. We can get information on the correlation and covariance of your data in your data frames. So what I'm going to do now is from ipython.display, I'm going to import YouTube video. And this is going to allow me to actually show you some YouTube videos. So in case you're feeling, if you feel like you need a refresher on covariance and correlation, or you just want to just learn a little more statistics, since you're going to need to understand covariance correlation for the rest of this lecture, there's some really great videos on YouTube, the best sources on the internet that I found for learning basic statistics. And I'm going to go ahead and put the links here so you can see it. And again, you can just grab these from the IPython viewer notebooks on GitHub. So this first video, this is for understanding covariance. The videos are made by a man named Brandon Foltz. They're really great videos. And the second video is on understanding correlation. So go ahead and check out these videos if you're feeling not so fresh on covariance and correlation. So, and then once you've gone over these two videos, you can come back to this lecture and learn how you can find the correlation and covariance on values in your Pandas data frame. Okay, so now that you understand covariance and correlation, let's go ahead and make a data frame, get some information. So what kind of information do we want? It might be interesting to see correlation and covariance on some stock prices. So in order to do that, we can actually use Pandas to get information off the web. We're going to learn how to do this in much more detail later, so that you can think of this kind of as a sneak peek of what you're going to learn in the future. So what I'm going to do first is import pandas.io.data as pdweb. This is going to allow us to get some information off the web. Then I'm also going to import datetime, just a Pandas library for date input. And then I'm going to create a data frame called prices. Well, let me import these first, make sure I didn't make a mistake. Perfect. So what can we do to get some prices? Well, we'll call PD web, and then we're going to call get underscore data Yahoo. So there's a lot of built-in methods to get stock prices automatically from the web. And all you got to do is input symbols, the dates you want them for, and then what kind of values you want off the stock. You can also get it off Google Stocks and various other sources. We'll be learning about this much more in detail later on. So this is kind of just a preview. So for correlation and covariance, let's go ahead and check out maybe some oil companies. So I'm going to put some stock symbols for oil companies such as ExxonMobil or British Petroleum. These are some of the largest corporations in the world, so it should be interesting to see their stock price data. And we'll say the start, this is where we're going to use date time. So I'm going to start it from 2010, January 1st. And I'm going to end datetime. And let's end it just 3 years later, so 2013, January 1st. And then the value I want off of this is the closing price, which in this case is going to have to be pass the string ADJ space close. Alright, and again, don't worry, we'll be going over this in much more detail in the future. This is kind of just a sneak peek on how to get information, financial information off the web. Let's see if this worked. Alright, took a little bit, but it got it. Prices.head. So .head just allows you to see almost like a preview of your data frame. So it's just going to show you the first couple values. So we have our 3 stock tickers symbols as the columns, and then the date as the index, and the actual stock price. So now we have a data frame full of stock prices, so that's pretty awesome. Let's go ahead and get the volume of the trades. So in order to do that, I'll do something really similar. I'm going to say pdweb.get underscore data underscore Yahoo. We'll pass the same ticker marks, the symbols. Whoops. And let's capitalize that X. And we'll do it for the same time frame. So the start time frame will be datetime 2010-11, and we'll have, whoops, forgot to put the day. We'll have the end be datetime 2013-11. And in this case, what I'm going to call for is the volume. Last time we called the closing price, this time I'm going to ask for the volume. And it looks like I messed up some syntax, and what I forgot was a comma to separate the start and the end. Let's try that again. Okay, and let's go ahead and just use the method head to see the head of that data frame. Just get a preview. Cool. So this is the amount of stocks that were traded on each of those days. So the total volume of stocks. So what would your return be? So the return would be the percentage change in prices in your stocks. So let's go ahead and call an object rets for returns. And then from your prices data frame, the method you can call is %change. So now you have the returns on your stock. And let's say you wanted to get the correlation of the stocks.
How would you do that? Well, we can set another object, and we'll say we can pass the correlation argument, which is .corr, on that new returns object that we made by getting the percent change on the prices data frame. Let's run that and see if that works. Awesome, it did. So let's just get a rough idea of what these prices look like. So in order to do that, I'm just going to call plot method on this data frame, prices. And again, in the future we'll learn a lot more about all this. This is just to get you a little taste of the correlation and covariance. So it's going to plot that from prices. Okay, so notice that I didn't actually see the plot. If I want to see the plot, I have to call a special command. We've seen this in the past. We've got to call matplotlib inline. So let's try that again. All right, awesome. So now I'm actually seeing the price of each stock, and you can kind of see how they relate to one another, especially the tickers CVX and XOM. You can see that they're really correlated to each other, especially around maybe September 2011. There's a dip, and then the rises seem to be really similar. The British Petroleum stock, it doesn't seem to be as quite high of a correlation, but there's still definitely some correlation there, just not as close as the CVX XOM. So what if you wanted to plot out this correlation? Well, again, here's another sneak peek at what we're going to be learning in the future. We're going to import Seaborn as SNS, and I'll go over this in much more detail later, but Seaborn is going to be a plotting library to help us visualize some data. And then I'm going to import matplotlib.pyplot as PLT. And let's go ahead and import those two. Let's see how they work. And now we can use Seaborn SNS to make a correlation plot. And Seaborn can do that just by passing core plot. What we're going to want to do is get the data. So if you remember before, we have our returns data set as the object RETS. That was just a percentage change in prices. I'm going to set annotation as false so we get a clear picture. And I'm also going to set diagonal names as false. And this is just to make a clear picture, but we'll have a whole section on learning Seaborn in the future. We're going to learn a lot about it. It's going to make some really great plots. This is just to give you a preview of what that looks like. And here you have a really nice plot here, and it's actually showing you the correlations between them. So it looks like XOM and CVX have a really high correlation, 0.8. That's pretty high. And if we look up here to the actual prices, that really makes sense. If you see, they're really correlate with each other. When one goes up, one goes down. I mean, these curves look very similar. And that shows in the correlation data as well. So awesome. So now you've seen it visualized, one kind of in the back of your mind. You can see how this would be highly correlated. And then mathematically, you've actually done the correlation, seen that it has numerical values to it. And then last thing we can do after that preview, let's get back a little more on track to stuff we want to learn right now. We can check for unique values and their counts. So in order to do that, I'm just going to make a quick series. And let's just make this, let's just have it be a bunch of letters. So I'll say WW, throw in an X, throw in a Y, throw in a Z, throw in another W, and just a couple more letters just so we get a good feel for this. And then finally, I'll put an A at the end, something unique. I'll show the series. And whoops, sorry. I should be passing a list into the series. So we need those brackets there. Let's go ahead and see what it looks like. Alright, so you got your series, bunch of letters. If we wanted to grab the unique values, I can do that by passing the unique method. And now I get an array return with each of the unique values. So W, X, Y, Z, A were all the unique values. What if I wanted to know how many of each of the unique values there were? I can say value counts. And now I know how many W's, X's, Y's, A's, and Z's there were. Okay. That's it for summary statistics. Next, we're going to learn how to deal with missing data. Let's just quickly scroll up and see what we learned. So the important takeaways here are learning how to call different summary methods onto a data frame, such as .sum, .min, or .idxmin, or .idxmax, or calling min. Really useful feature. The main thing you get out of this, describe. Describe is super powerful, and we'll be using it quite a bit throughout this course. To give you a little taste of the future, we went over covariance and correlation, and how we can grab information off the web using Pandas, just to give you a little taste of what you can really do some amazing stuff with Pandas. And then how we can plot, and how we can make really good looking data visualization plots using Seaborn, which we'll learn about Seaborn and plotting in the whole other section on data visualization. Alright, awesome. And then we can check for unique values in a series or data frame, and we can also get their value counts. Cool, so that was summary statistics. I'll see you on lecture 23. Thanks. Hey guys, welcome to lecture 23. And this will be on missing data. So we've seen a lot of examples of how Pandas deals with null values and missing values, so we're just going to go and dive a little deeper into that. So, as always, just copy and paste or type out the usual imports. NumPy, from Pandas, import series and data frame, and import Pandas as PD. Alright. So we're going to learn how to deal with missing data. It's going to be a really common task when you're analyzing data sets. So let's go ahead and make a series. We'll just call it data. And we'll pass a list in it. We'll just say 1, 2, a missing value, and then 4. Let's go ahead and see what that looks like. Alright, so we have our series, 1, 2, null value, 4. So, how do we find these missing values? So Pandas makes it pretty easy. You can just pass the method isNull, and it will tell you true if there is a null there. So in our data, index 2, we had a null value. If we pass the method isNull, it'll find it and relate it back to you as true. We can also just simply drop and remove all null values, and if we want to do that, we can just say drop NA and pass that method on our data set. And so anything that had a null value is now gone and it's been dropped. Let's see, so that's how it works in series. Let's see how it works in a data frame. So let's make the dFrame object. We'll call it data frame. And let's go ahead and we'll make the first row of this data frame 1, 2, 3. We'll make the second row start off with a null value 5, 6. We'll make the next one 7 null value 9. And then the last row, I'm just going to make this all null values. Alright. And then let's go ahead and see that data frame. Cool. So now we have a data frame. It's a 4x3, and there's several null values there. And now let's go ahead and make another data frame called clean dframe, clean underscore dframe, and see what happens. We'll set that equal to drop NA. So what's going to happen is if we drop every null value from a data frame, let's go ahead and see that result. So you end up only getting 1, 2, 3, that first row at index 0. What Pandas does, if you just drop NA with no additional arguments from a data frame, any row that has any null, even if it's just 1, is going to be dropped from that data frame completely. So we can also specify to only drop rows that are completely missing all data. The way we can do that is drop NA, and we can specify the method how. And if we specify how all, then that's going to drop rows where all the data was null value. So you can see here now only the third row was dropped, since that was the only row that had all null values. We can also specify to drop columns instead of rows, and the way to do that is by just specifying the access. So we'll say access equals 1, and we'd expect this to drop all of them. And why is that? Because if we look at our original data frame, every single column had a null value in it, so every single column got dropped if we just specified access equals 1 with no additional arguments. Cool. So we can threshold the missing data as well. For example, if we only want rows with at least 3 data points. So to show you how that works, let's go ahead and make another data frame. We'll call it dframe2. And I'm just going to make this I'll make it a 4x4. And to make this go a little faster, what I'm going to do before I start this data frame is I'm going to set npn equal to np.null, or excuse me, np.nan. That way I can just write npn. So let's start off with our first row. I'm going to say 1, 2, 3, and then last value npn. Second row we'll do 2, npn, 5, 6. Next row the list we'll put in is npn 7, npn 9. And then the last one will just be 1 with the remaining 3 values be npn. So that should give us a 4x4. And then let's go ahead and see what that looks like. Cool. So now we've created our data frame with a bunch of null values. So if you want to threshold by number of actual data points, points that don't have a null, you can do that. So you can say drop NA and then pass the thresh argument. So that's thresh, and let's say I only want rows that have at least 2 data points. So I can pass the threshold 2, and let's see what that comes up with. So now, since the last row, 1 null null null, didn't have a minimum of 2 data points, it was dropped. The other rows, even though they have null values, have at least 2 value points. So they weren't dropped when I put the threshold. Let's go ahead and just make sure we understand it. So I'm going to drop NA with a threshold of 3. So just think about for a second which rows you think are going to be dropped. Remember, threshold is going to drop any row without at least 3 data points. So the first two rows, index 0 and 1, have at least 3 data points, so they got to stay. Let's take a look at dframe 2 again, the original. Alright, so let's say you wanted to fill where you had null values instead of just dropping them. You can do that with the fill NA method. So if I wanted to fill all the null values with a 1, I can pass the argument 1 into fill NA, and now any values that had null, for instance, this last row, now have a 1 value there. Great. And let's go ahead and, sorry, I called the original dframe. Let's check it on dframe 2. There we go. Now that makes sense. We have our 4x4. Awesome. So what else can we do? We can also fill in different values for different columns. So to show you how that works, we'll call it on our dframe 2. Let's just see what that looks like. The original still has all our null values. Remember, since we're not setting anything equal to these method calls, since I'm not saying dframe2 equals dframe2.fillNA, we're not making actual permanent changes to the dframe. So I can always call it and still have those null values. So dframe2.fillNA, if I want to fill in different values for different columns, what I can do is I can pass a dictionary. So let's say the 0 column, I want any null values filled with 0. The 1 column, I want any values filled with 1, null values that is. And then we can do the same thing for the other 2 columns. Take a minute, think about what this is going to look like before we see it. Let's see if we got it. Alright, cool. So now anywhere there was a null value in a particular column, we replaced it with the number of that column. So if we look at column 2, for instance, the last 2 now have a value of 2. Excellent. If we want to modify the existing object, there's 2 ways we can do that. We can either say dframe2 equals dframe2.fillNA, etc., etc., or that's a method of affecting the data frame permanently. But if you want to modify it in place and not have to type in equals like that, we can pass the argument in place. So fill NA, that would fill all those null values with a 0. Now notice I call dframe2 again. Those values go back to null. If I want to make the change permanent, then I can say fill NA 0, and I'm going to pass the argument in place. If I set it as true, that means it's going to modify the existing object. So let's go ahead and take a look at dframe2 now. And you'll notice just calling the dframe2, I no longer get null values. It's been permanently changed to have zeros instead of that null value. Alright, so now that we've learned how to deal with missing data, next we'll learn about index hierarchy. I'll see you there. Hey guys, welcome to lecture 24. This is going to be on index hierarchy. So in this lecture we're going to learn about hierarchies and index formation. So you're going to be able to have almost like an index of an index. And I'll show you what I mean about that later in this lecture. So let's go ahead and start off by just importing the usual. Import NumPy as NP from Pandas. Import series. Data frame. Import Pandas as PD. And then since we're going to be using random numbers later, as we've done in the past, we're going to import from numpy.random. Going to import rand n. Okay, cool. So Pandas allows you to have multiple index levels, and I'm going to show you with a quick example on a series. So let's go ahead and make a series called SER. we'll call the series. Let's construct it using np. We can construct it using random 6. Just make 6 random numbers. We'll create an index. And you'll notice that my index is going to be 2 lists. So I'm going to pass 2 lists in my index. First list, I'm just going to say 1, 1, 1, 2, 2, 2. And then my second list, I'll have it be letters. So we'll say A, B, C, whoops. And then we'll repeat it again, A, B, C. So usually we're only passing one index, but now since we're going to learn about index hierarchy, we'll be doing multiple indexes. Let's go ahead and see what that looked like. Cool. So what Pandas did is it created a multiple index level, so it matches up the 2 lists you gave it and assigns one index level to the other one. So for instance, since your first 3 values of your first index list were 1s, then it assigned that 1 index to the first 3 values of your second list. So those first 3 ABCs were all assigned on the 1 index, and then you have a sub-index of ABC. And then similarly, the 3 2s were assigned to the second set of ABC. So we can also check multiple levels. So if I, for instance, call the index method on my series, it'll give me the number of levels and their labels as well. And let's say I wanted to check a specific subset. So if I wanted to check, for instance, the first A, B, and C set, so the 1 in index 1, I can call it, and I'll get those first 3 values. And if I called the second index, I would get the second ones, 0.93, 0.157, and then 0.411. Let's say I wanted to call an index from an internal index level. So let's say I wanted to know everything on the series that was associated with an A. So I want to know both this value, 1A, negative 0.34, and I also wanted to know the second A, 0.934. The way I can do that is by selecting everything using a colon in the higher index level, and then specifying that I want all A's in that lower index level. And there you go. It gives you that outer index level, and then the 2 values that were associated with the inner index of A. So we can also create data frames from a series with multiple levels, and we can do that using a method called unstack. So we can name our data frame dFrame, and then call the unstack method on that data frame. And then let's go ahead and take a look at what happened there. So since you had multiple index levels, now you can create a dFrame using unstack, and it'll create the lower index levels as columns, and your higher ones will be now the index of the rows. And we can also apply multiple level indexing to data frames since the very beginning. So if you wanted to construct a data frame with multiple index levels, we can do it like this. So I'll show you an example. So you have your data frame, you have np.arrange. So we're going to choose 16 points, and then let's reshape this into a matrix. We'll just have it be a 4x4 matrix. And then we're going to create an index. And again, so we're going to pass 2 lists in the index. First list, I'm going to have it be 2 pairs of letters. And the second list, I'll have it be a set of numbers. And then we can also do subsets of columns. So how can I do that? Well, we can specify that the columns is also going to be a set of lists. So let's have a first column be cities. We'll call NY and Y. Let's say LA and SF. And then the next one we'll do cold, hot. Let's just do hot, cold. All right, awesome. And then we'll have dframe 2 to show it. So let's just see what happened, and let's go over what we just did. So we created a data frame. We arranged our 16-point array, and we reshaped it as a matrix. So if you look on the inside, you have 0 through 15, so that makes sense, and it's a 4x4. And then we passed 2 index lists, AA, BB, 1, 2, 1, 2. So each of these gets matched up. So now these first 1, 2s are associated with A on the outer index, and then the second set of 1, 2s are associated with B on the outer index. So that's what we got going on those index of rows. And then if we wanted to make an index hierarchy for the columns, we can do the same thing. We created NY and YLASF. That's going to be your outer index. And then your sub-index there, we decided to be cold, hot, hot, cold. And that's what we got here. And they're associated with the first value on your first list is associated with the first value on your second list that you pass, and so on. Second value NY associated with the second value here, hot. So you get that going on your data frame. So if you want to keep better track of your index levels, you can name your index levels. So let's see how to do that. So let's go ahead and name our index levels. And we can do that by passing index.names method. And since we have multiple index levels on the rows, we can just pass a list. So we'll say index, index 1 for that first row index, index 2 for that second row index, and then we can also name the columns. And we can do it by just passing the method columns and then passing in names on top of that. And let's call our column names. So it looks like, so the first index for the columns are cities. So I'll call it cities. Oops. And the second index is temperature, well, more or less hot and cold. So we'll call it temp. And then after doing that, let's just see what the data frame looks like. Cool. So now we have the names of those indexes. So your first index, the AB, your second index, the 1, 2, 1, 2, and then your column names, cities, and temperatures, cold, hot, hot, cold. Cool. Let's say you wanted to interchange the level orders for some reason. You can do that. So if I wanted temperatures to be the outside index and cities to be the inner sub-index, how could I do that? So you grab your data frame and you pass a method on it called swap level, and then you give it the two index levels you want to swap. So we want to swap cities and temp, and we're going to set the axis equal to 1 because we want to swap the columns. If we don't put an axis, it'll try to swap the axis 0 by default, and that would be the rows. So since we're swapping columns, we're going to input 1. Let's see what happens. Nice. So now you can see we've swapped the levels. So now the temperature is on the upper level, cold, hot, cold. And you have your cities that are associated with those temperatures. You can also sort levels. So if you wanted to sort a level, you just pass the method sort level. And let's go ahead and pass that and see what happens. So now if we look at the row indexes, they've been sorted. So 1, 1, 2, 2. And what this, the argument I passed here in sort level is for which sub-level of the index to sort. So let's say I passed a 0 instead. Well, now it's going to sort it by the outer index, A's and B's. So those are already sorted. If I wanted to sort it by the 1 index, so remember index 1, that's your 0 index here, index 2, that's your 1 index, since it starts at 0, and now we've sorted it by the second index, so 1, 1, 2, 2. We can then perform operations on particular levels. So this is where it gets interesting. We take our D frame, and let's say we wanted to compute a sum. But if we only wanted to compute a sum on a certain level, for example, we can pass the level argument, and I only want to compute sums on the temperature level, and I want to compute the sums on the columns, so I'll pass access equal to 1. Let's see what happens. So now I've kind of ignored the cities since I specifically stated the level to be temperatured, and I've added based on the temperature level. So let's look and see what happened there. If we look at our previous data frame, index 1 is A, index 2 is 1. What are all the cold values equal for this index? Well, it was 0 plus 3, and now you have 3 as your cold. And then the hots were 1 plus 2, so now you have 3 by your hots. And you can take that and expand it to the rest of the rows and columns, and that's what you get. Cool. So we'll be messing around more with index hierarchy in the future. It's going to be a really useful tool. That's the end of this section. Next up, we'll look at section 5. It's going to be working with data, the first part. You can go back on previous lectures, get a little more familiar with data frames and series if you want to, and we're going to be reviewing and using those tools a lot through the rest of this course. So